is going to be kites. The reason 6-6 trapezoids and kites are together is because neither one of them is a parallelogram. Everything else we talked about is parallelogram. Kites are not a parallelogram. Trapezoids are not a parallelogram. Everything else, rectangle, rhombus, square, those ones are. So 6-6b, definition of a kite. You've probably seen this figure many a time, just maybe not in a mathematical sense. So we're going to talk about what we know about it. A kite is a quadrilateral, so four-sided figure, that has two pair of consecutive. What's consecutive? The ones that are next to each other, right? Consecutive angles, so angles that are next to each other that are congruent and no opposite sides that are congruent. So you can't have sides across from each other that are the same. In other words, this side cannot be congruent to that side in a kite. It will not happen, okay? But your consecutive ones will be. So you'll have two pairs of consecutives that are congruent. These two will be congruent, and those two will be congruent. So like in the figure right next to that, we would say these two are the consecutives that are congruent, and these two are the consecutives that are congruent. Do you think any of the angles are congruent? If I drew this line in, that'd be reflexive, right? And we would have SSS. So that means, take the line away, that this angle would be congruent to that angle. The top is not congruent to the bottom, but if I did draw the line in, then it would be true that this one is congruent to that one, and this one congruent to that one. Okay, so if you draw that bisector in, you do get two congruent triangles there. But just in general, only the two where your non-congruent sides meet are congruent. So for instance, if we look at that next picture, this angle here is congruent to that angle, but not the other two, okay? Okay, next theorem. This one is a lot like rhombuses. It's exactly like rhombuses in this theorem. It says the diagonals of a kite are perpendicular. Okay, so every single kite will have 90-degree angles for those four angles in the middle, every time. It cannot be anything different. Notice, like we said before, if these are our congruent sides, those two and those two, these angles will be the same. These angles will be the same. The other diagonal also makes these two the same. Oops. And the ones below it. Sorry, this is, we really should have just zoomed in. We're going to do that. Hold on. Because this is a mess. So we would know those are congruent. These are congruent. These are congruent. Okay. So you do end up with a lot of congruence, but a lot of stuff that's not as well. So just make sure you pay attention to that. I always tell people if they can't remember which ones are, if you draw a really extreme kite, like a really long diagonal this way and a really short one this way, you can usually see which ones are the same if you have trouble remembering which ones are the same. So if I were to do it like this and draw my kite, I can tell right now that like this angle is not the same as that one, obviously, right? So the more extreme, the more lengthy and short the other way that you draw, usually the easier it is to see it. Yeah?
Would half of the horizontal bisector be parallel to the other half?
This congruent to this, you mean?
Yeah, on the other diagram.
This congruent to, oh, over here?
Yeah.
Yes, this segment would be the same as that one. Yeah. Yeah, these are not, but the other one is. Questions on that? Yeah. back to up here?
Yeah.
Yeah. Okay, so what you're going to be doing a lot on this test is just finding angle measures for different figures, much like this example 4. So it tells you these are kites, which means these are the same and these are the same. Find the values of the numbered angles. So what's angle 1 going to be? 1 is 90, right? All of these angles would be 90 degrees. Okay, so angle 1 is 90 degrees. Angle 2, this is bisected, right? Because we made 2 congruent triangles there. So angle 2 is either one of those angles. They'll be the same measure. So if you look at this triangle, you have 90, 40, and angle 2 that have to add up to 180. So 90 plus 40 plus the measure of angle 2 equals 180. So what's the measure of angle 2? Would be 50. Okay. Questions on that? All right, so let's look at this kite. These 2 are congruent. Those 2 are congruent. What's the measure of angle 1? 90. Kites will always have perpendicular diagonals, so these are all 90. Can you tell me the measure of angle 3? 3 is 36. So this right here is going to be a bisector every time when it's cutting the 2 congruent sides. Okay, so that's 36. So then how do you find the measure of angle 2? Right, 36, 90, and the measure of angle 2 make a triangle, so that has to add up to 180. So take away that 126, and your measure of angle 2 will be, what does that work out to? 54. Okay. Questions on that? Okay. Last thing then, I pulled this from the book. It's really just a good visual to help you keep it all straight. So we've talked about 1, 2, 3, 4, 5, 6, 7 different quadrilaterals. All of them over here are the ones that have 2 pairs of parallel lines. So everything that is a square is also a rectangle, a rhombus, a parallelogram, and a quadrilateral. Okay, so everything on the bottom is everything above it. So a trapezoid is a quadrilateral. An isosceles trapezoid is a trapezoid and a quadrilateral, right? So you're kind of working vertically in reverse, I guess you would say. A parallelogram does not have to be a square, but a square has to be a parallelogram, right? A rhombus does not have to be, I said that wrong. A rhombus does not have to be a square, but a square has to be a rhombus, okay? A parallelogram doesn't have to be a rhombus, but a rhombus will always be a parallelogram. So it's just kind of giving you the relationship between them. What I want to do real quick, just as we kind of finish up this lesson, is I'm going to walk you through a couple little worksheets that are linked. If you click on, if you want to see these and fill them out yourself, you're welcome to. You don't need to. This is not homework, but we're just going to kind of do it together just to make sure you've got the properties. If you click on quiz 6.4 to 6.6 in Canvas, there are 2 files in there that we're going to walk through real quick here. Hopefully. So the first one, we're going to do the quadrilateral review. Looks like this, okay? So I just want you to think through this with me. There's all these different figures that we talked about, this list up here. Can you tell me which one fits best? Okay, so best describes, not can describe, but best describes a parallelogram with at least one right angle. What would that be? Best name you can give it. A rectangle, right? If it's a parallelogram, opposite sides have to be parallel. If it has one right angle, remember rectangles have consecutive angles that are supplementary. So it'd go 90, 90, 90, 90. Doesn't say anything about the lengths of the sides. So best name you can give that is a rectangle. Okay? How about a quadrilateral with exactly one pair of opposite sides parallel? This being the key word. Exactly one pair. Trapezoid. It might be an isosceles trapezoid, but they don't tell us information to say that it's isosceles, so the best name we can actually give it is just trapezoid. Okay, so that'd be G. A four-sided polygon. Best name you can give that. Quadrilateral. It might be something more specific, but as much as they told us, we know it's a quadrilateral. Okay? A quadrilateral in which two distinct pairs of consecutive sides are congruent. That's a kite. Okay? Distinct pairs means two separate pairs. So that would be a kite, consecutive, right, next to each other. A quadrilateral with both pairs of opposite sides parallel. Not polygon. Parallelogram, right? So yes, parallelogram. So number 6, this one gives you a good detail here. It says it's a parallelogram, so that rules out which ones? Kite, trapezoid, isosceles trapezoid, right, are not going to be parallelograms. With at least one pair of consecutive sides congruent. So you have a parallelogram, right? These are parallel, and these are congruent. Square is too specific because it doesn't tell us anything about the angles, right? Not a rectangle, the other one. Which one has congruent sides? Rhombus, right? Opposite sides would be congruent in a parallelogram, so those are the same, those are the same. So we just know it has 4 congruent sides, technically. So that would be a rhombus. That's D. A trapezoid whose non-parallel sides are congruent. The isosceles trapezoid, right? That's H. And then a parallelogram that's both a rectangle and a rhombus. That's a square, okay? So square for that one. Okay, here's how you're going to see it on your test and your quiz. You're going to get a picture, and there's going to be markings, and you're going to have to tell me, here's the name I can give. So number 9, the most descriptive name you could give that. And this one's tough because it has one pair of parallel sides. I guess it depends how you look at this. If that's saying it only has one pair of parallel sides, what would it be? A trapezoid, right? I don't know if they want us to see this as it could have more than one. That's creepy. I wouldn't give you that one. I would probably take on that trapezoid, or you could just say quadrilateral because we don't know if there are more. But I think what they're getting at here is trapezoid. We're just gonna, I'm not doing letters anymore because won't see them. How about that next one, number 10? What? This would be rhombus. This is the one we just did earlier, right? It's a parallelogram. Opposite sides in a parallelogram are congruent, so those would all be congruent, so that would be rhombus. Okay, how about 11? Do you know anything about lengths of sides? Anything about angles? No, but we know sides are parallel, so it's a parallelogram. Okay. Number 12? It's a quadrilateral. We don't know anything about it. Sorry, that's a really messy quad. How about that one? One pair parallel, Other side's congruent. That's an isosceles trapezoid. See what I mean about all of them look like a square, but very few of them actually are squares? Pay attention to the markings. 14. That is a square. Opposite sides would be congruent. Consecutive angles are supplementary. Opposite angles are congruent. So that would be a square. That's RE. 15. That's a kite. Consecutives are congruent, right? These two are the same, and then the other two are the same. That is a kite. This one's a little tricky. A what? Rhombus? Not rhombus. Which one deals with angles? So, do we know all the side lengths are the same? No. But we know because these lines are parallel, because these angles are congruent, the lines will be parallel because those are alternate interiors, right? So we know it's a parallelogram, and we know we have a right angle. Well, that means this is a right angle, that means that is a right angle, that means that is a right angle. Rectangle. Okay? Questions on that? Yeah. There is one other worksheet in there. I'm not going to walk through it with you right now because I feel like this does a good job of getting you there. But if you want to just try for yourself and come up with all the properties, or if you would like to see it, I'll fill it out for you. I don't want to make you sit through it right now. So totally up to you. I will put it up if you would like to see it, but we're going to stop there for now.